Alright, hello everyone. I'm Professor Caudill. Today we are on 78. Almost finished. Got about 20 or 30 problems left in this physics chapter. So, last video was pretty tough. We got pretty stuck on these. So hopefully this section is a little easier. Defining velocity and displacement, acceleration. So this should just be easy calculus. Find acceleration of particle with time according to equation. So we have A is pt squared minus qt cubed. I'm guessing q and t are constants. So velocity and position are 0. So s t is 0, or I should say s at t equals 0, 0. And then velocity at t 0 equals 0. So that's what I think it's saying. So we don't know what is the velocity as a function of time. Velocity as a function of time. So we want to find vt, so we're going to take integral p t squared minus q t cubed dt. Okay, so it's going to be, you're going to pull out the q, so it's going to be p over 3 t cubed minus q over 4 times t to the 4th. So that should be our velocity function. And then if you want the position function, you're going to take the integral of p third t this q4 t4. So you're going to get p 3 times 4 is 12, t to 4th. So 4 times 5 is 20. So q20. That's going to be our position function, and that could also be written as x of t. Depends on preference. So I did take the liberty to pull out the answers. So, and these should be added by a constant c1 because we're taking an indefinite integral. So same thing here. We're just going to tack on a constant at the end. That's the one thing I missed. Definite integrals with bounds like b, a, you're not going to have a constant. Okay, so they got not sure why this is 5. This just seems like a mistake here. Meters per second to the 5th divided by 2. I have no idea what they're saying there, but so they're getting for velocity 0 is c1, so it's 2/3. Yeah, these answers are not right either. Okay, it's because this is 78. We're on 78. This is 79. So we're just not ahead yet. It's like I wish the book just did all, like, it's like, why do they do the only the odd numbers in the back of the book. All right, so I mean it's hard to get this wrong, I think. So let's just move on to 79. See if we can do it ourselves before we look up the answers or get a second opinion. Okay, so t between t is 0 and t is I'm gonna rewrite this. T naught is 0. T1. T is 1. I don't like that notation either. Alright, well anyways, rocket moves straight upwards. With acceleration, at is a. I really wish the book would specify these are constants. But I'm going to assume they are. So a and b are constants. Okay, so thank you. X is in meters. I'm guessing that's the position function. It's position. X is position. T is in seconds. What are the units of A and B? Okay, A and B. So I immediately want to say it should be in meters per second squared, but I don't think that's right. Maybe they would just be in meters, and then you take meters times time to get seconds squared. So I'm gonna guess meters. Let's check if it's meters. A is meters per second squared. B is meters per second 5. Okay, so let's go ahead and integrate. Okay. So that's going to be AT minus B times. So this is going to be T to the 3/2. So we're going to times it by the reciprocal. So it'll be 2/3. T 3/2. It's the velocity. So we want to get this down to x of t. So we're going to take the integral again. At minus 2b thirds t 3/2 t. Okay, so what happens next? It's going to be, you're going to pull out the constant outside the integral, and you're just going to take the integral of t, so it's going to be a t squared divided by 2. Okay, so then we're going to subtract. So this is going to be 5/2, so it's going to be 2/3 b times 2/5 times t 5/2. Okay, so as you can see, these let's call it, we can just call this C1, some constant, C1 t squared plus C2 t 5/2. So this is meters. So meters per second. So what the book's getting meters divided by second squared. I'm getting meters times second squared. So I guess they're just writing this as meter per second squared. I don't really know exactly why. But like from looking at it, it's like meters times second squared. But for some reason there's a negative sign here. So I'm not sure where that negative sign is coming from. As far as I can tell, we have done everything correct. Because when you take an integral, if this is t to the 1, you take the integral, it's going to be t 1 plus 1. Same here, this is really t to 0. You're going to add 1. So t to the 1. That comes here. So, all right, so let's do the next part. Rocket starts from rest. So start from rest. What is the velocity? How does the velocity vary between t0 and so we want the velocity given the acceleration. So a t. Okay. Yeah, so vt is a t minus 2b thirds t3 halves. So they want to know how does the velocity vary between t0 and this is going to be plus constant c. If the rocket starts at rest, so it's rockets here, starts at rest, and this is t0 b0. So we're saying 0 so this is our first equation, and then our second equation. This is the rocket. Our second equation is going to be t naught. So I don't know what else to do besides that. Let's see what the book is getting. A t0 minus 2/3 b t to 3/2. B naught equals 0 equals C1. Okay. So that makes sense. V naught or V0. So you can plug these in. These are going to get 0. So you're going to get left with C1. Okay, I can see that. So T naught. So they're going to take this out, I guess. That's what they're saying. Okay. If the initial position is 0, so that is S. Initial position 0, so that's S of t is 0. Okay. During the same interval. Okay, so they want to do S of 0. It's going to be so it's going to be 0, 0. Is it just C2? Is it just C2? I mean, it's going to use this. Okay, so yes, they get C2, but its x is 0 is C2 equals 0. Okay. So they get 1/2 a t squared t naught. Okay, so you're just going to add a little subscript here. That's all they're doing. Doesn't make super much sense to me, but at least I can do the calculus, I guess. Velocity of a particle moving along the x-axis. Holy, can I even draw a straight line with an arrow? All right, so velocity of a particle moving along x-axis with time. So it's following this equation: bt equals a plus b t negative 1. A is 2, b 2.5 meters per second, and t is between 1 and 8. Determine the acceleration. So we're going to find the acceleration. So we're going to take a t is dv dt. That's going to be zero plus b times t negative 1 minus 1 times negative 1. It's going to be negative b over t squared. Okay, so we want to find the acceleration in position. Oh, it's annoying. So s of t is the integral of a plus b t negative 1 dt. I guess I'll write it out just for education purposes. A plus b t negative 1 dt. That's going to be a t plus. All right, so it's going to be b over b 1 plus 1 is 0. B divided by 0, 0. Okay. AT plus C plus some arbitrary constant. All right, so now we want to find a of 2. It's going to be negative b over 4. And we're going to find a of 5 is negative b over 25. And then we're going to find the position at the same times. So that's going to be 2a plus some constant s of 5 is 5a plus c1. Okay. Assume that x equals 1 second is 0. Okay. X at 1 second is 0. X at 1 second is 0. Okay, this is saying, really, it's just saying s at 1 equals 0. Okay, so how does that help us? If it helps us at all, it's gonna help us solve for either C or A or A, B, or C. So I don't know what to do next. So we'll look at the book. Oh, never mind. We're on a positive number in the book. See, I'm just gonna move on. I don't know why they gave us this. It's not ringing any bells. Okay, let's just move on. I think we got the majority out of that exercise. All right, so particle leaves particle at rest. Particle at rest leaves the origin with its velocity increasing with time. Okay, Vt is 3.2 t meters per second. So at five seconds. Okay, so they want to find the acceleration. Find the acceleration. Okay, so I think we can do this. AT is 3.2. Let's just rewrite this to 1.6 t squared meters a second squared. Okay, so that's our acceleration. Now it's saying A T with acceleration particle as a function of time. velocity starts decreasing. Okay, so B at 5. Just trying to figure out how to write like the math. Like, I haven't really dealt with something like this before. What is the acceleration of particle function time? So I don't know if this is what, if this answers the question. 81. Okay, so 3.2. Okay. So all right, so T is 5 seconds. How do they get that into here? So like I I get I get I got the middle part some like close. I got close to getting the middle part right. This top part, I don't get how they're getting 3.2. T is greater than 5 seconds. So I don't know if they're like setting, like, are they setting this equal to 16 minus 1.5? What's 5 times 1.5? What is that, 7.5? Add this to one, add this to both sides. 0.1 T is 0.1 T is 423.5. Okay, let's do 0.1, 23.5 divided by 0.1, 235. So not quite. What if they did 3.2? 3.2. Okay, let's try that. Let's try 3.2. I get 7. 7. Okay, so I'm not really getting it. So let's plug it into a let's consult a second opinion. Maybe it will help. Okay. So immediately Okay, so they're writing it like this. Of whatever v is at whatever v is. Okay, and where t, it's bounded. So I think that's what they're I think that's what they're trying to do. And they get negative 1.5. And they get positive 1.5 here. Where do they even get the 1.5 from? Acceleration's given 1.5. So it does make sense that it would be negative. So all right, so as you can see, this is why it helps to like have an experienced teacher, because relying on the textbook alone is it's hard. It's hard to self-teach yourself math and physics without a dedicated teacher, but it doesn't mean you can't make progress. It's just you're going to learn slower than someone that has, a personal tutor, which is it's obvious, but it's like it's worth just recognizing. All right, so a baseball player could pitch, so he's throwing. So V at, so he's throwing it 160 kilometers. Okay, so we're gonna okay, so let's write this as position. Then velocity 160 t. Okay, and then at is 80 t squared. So we know x not is 0, x is 18.4. So we're going to find t. So we're going to use it's v naught 0. V at. Okay. Let's try equation 4. So we're going 18.4, accelerating 80 times what we're solving for. Initial velocity is 160. Initial position is 0. So I am getting t 0.11 11 seconds. And compare this with the average reaction time of a human, which is 0.25. So if human reaction time R is 0.25, then it's the ball thrown. It's approximately two. It's approximately twice the human reaction time. Okay, 83. Airplane leaves Chicago. Airplane, so it's going, we have a vector going this way, 300 kilometers, makes 300 kilometer trip in 5 hours. So S of T is 300. Okay. T I guess I'm going to say S of 5. It's 300 kilometers. Okay, a second plane leaves. Second plane leaves 1/2 hour later. So is that 5.5? 1/2 hour. So one half hour later. So 5.5. Okay, so this one, S of so we have a plane that goes 5.5 and it travels 300 kilometers in that time. So we want to find the two velocities. All right, so let's say P1 and this is P2. So P1, let's say V. Okay, so okay. P2 is 5.5. So taking same distance, so it should be 3,000 times 5.5. Okay, so maybe it should be 4.5. So that's not right either. Be okay, what's 3,000? That's 5. It's 15,000. Oh man, bad algebra. Okay, so let's say this one goes this one goes 16,500 meters per second. So you can see line one travels 1,500 meters per second faster. Okay, 84. This is an odd number, so we can't check our answer. And I don't know what they're getting. 600 kilometers an hour. Okay. So they're probably just taking 3,000 divided by 5. That's gonna give you 600. And then they're gonna take whatever that is, 667. Okay, so maybe this is wrong. Maybe this is wrong. So what's wrong with our method? S of t is 5. Okay. So it's saying okay, so I wish they would show their algebra because I think I'm messing up trying to formulate it like a function. I mean, I guess I could write no. I don't know, kind of frustrating. Thought it was an easy problem. All right, 84. It was 16 kilometers east, 8 kilometers west, 32 kilometers west, and then 11.2 kilometers east. So V how long did it take him to complete his trip? Okay. So we know that distance is speed times time. Okay, and they're asking how long. So we're solving, we know the distance, that's the sum of our components. So it's going to be 16 minus 8 minus 32 plus 11.2 equals 24 t. So we can just write 24. So I'm guessing it's going to be a negative time and that's why it's going to not make sense. But we'll plug it in. Okay, see, we're getting a negative number, so this is not a reasonable time. Time can't be negative. So I think if we wanted to make it more reasonable, we'd probably add these. That way we get 2.8 hours. 2.8 hours, then it becomes more reasonable, let's say. Let's get a second opinion, just because we're kind of struggling with this, with these harder problems. So yes, we get negative 2 hours. This makes sense. Okay. Let's move on. Okay, we got 13 minutes left. So A at T is 40. Velocity at 4 is 3.4. So it's a really, it's got to be 3.4 times something to get 4. So really this should be 4. It's negative 3.4 T. So I I think that's what it's saying. Or it's saying, yeah, 4. Then we have 2 time variables. So that doesn't make sense. Because I don't want to make the same mistake we did on the earlier problem. So I just instinctively know this is not written right. At T is 4, so velocity is 3.4. Okay, so what is this saying in English? It's saying we have a function that assigns the number 4 to another number, and that gives us 3.4. Okay, so we're going to find the VT is 1.2 T. Okay, so V1 1.2. V6 is, what is that? 6. Oh, 1.2 times 6. 12. 7.2 centimeters a second. Okay. So these aren't making sense. We're getting a negative velocity at 4, but we're getting positive velocities in between. Okay, this is an odd problem. So they're using the average velocity function. Okay, t at 0. That doesn't help me at all. Doesn't help me learn at all. All right. T is 1. T is 1. T is 6. Okay, that's it. Okay, so that this is using a totally different kinematic equation. Okay, so I wrote this kind of right. This is kind of right. AT, this okay, this is right. V naught T. So we're gonna use VT equals V naught plus AT. Okay, so VT is, it's gotta be 1.2T. It's gotta be the integral of itself equals V naught. V naught is negative 3.4 plus 1.2. That makes sense. 1.2 times 4. Negative 3.4. So we're solving for V naught. Okay, so how do we get this? What is a question? How do you get V naught from this? Determine its velocity at t is 0. Okay, so they're getting a number. So V naught is 8.2 meters per second. So just ignore all of that. Okay, so 8.2. So now they're gonna plug that in. Okay. It really is just a struggle of converting English into math. Really, that's really just the hard part of it, I'd say. And I don't think these answers are even right. -7, -1, 8.2, -7, -1. Okay, so it does get the same thing. Okay, so we used v is v naught plus a t, which is the same as saying vt v naught plus a t. Okay. Now the book uses v minus v. Okay, so let's rearrange this. A t minus t naught equals v minus v naught. A t minus t naught equal plus v naught equals v. So as you can see, this gets rewritten as that. So, or you can write it like we can rewrite it as that. So it seems like a useful. So they're converting this into that. So it's kind of a lot. Let's see. Can I write this in LaTeX? Why do I have caps lock on? Okay. Let's say oh, okay, so we have a function. I want to write function b is a times t. Okay, so we're gonna have to add a t naught. T minus t naught t0 plus v naught. And oh, come on. Yeah, break. Okay, so I've just written it in LaTeX. So now, hopefully, we don't forget it. I haven't added this to this yet. Then that'd be a kind of a headache. And I could do it, I guess. Wouldn't be too bad, but for now, this is just like a visual reminder. I don't know. I guess I should just write a function for it, shouldn't I? All right. F0. What's our term? So it's kind of like it's kind of like F3. So let's rewrite this as equation of motion. So F3, it should be about the same variables as F3. So we're going to solve PAT, T naught, T naught, B, okay. Equation 0. Okay. We have to add 0 is F0. Lift. Okay, so V function turn function 0. Okay, so we're going to return. So this will be okay. So I don't know if this will work first try. Could be pretty lucky. 5 minutes over. Invalid syntax. We have 2 commas. Find function 0 commas. elif, elif, elif. If okay, T0. Yes, I did forget a comma. Okay, so let's test this out. Function 0, final velocity 4, acceleration 0.2, final time 5 seconds, initial time 1 second, initial velocity 2, result is 0. Well, that's because we didn't choose anything. Okay, so 0, final velocity is 5 meters per second, 1.2 meters per second squared, final time, that's what we want to solve for. Final time is t, initial time is 2 seconds, initial velocity is 4 meters per second. So then that gives us, okay, so there you go. I just added equation 4, equation 0. It's basically equation 3, but it's drawn out. All right. Thank you guys for watching. I'll see you next time.